Good to see you all. I'm Ko Young-jun from GI Innovation. So I'll begin my presentation from now on. And before I begin, I'll mention that Chang Myung-ho, CEO of GI Innovation, and Lee Jun-heng, Big Bio CEO, will cover the discussion center. So today I'll cover the NK cell targeted immuno-oncology, and this slide is the disclaimer. And first of all, in the global market, we're currently working on NK cell targeted IO therapies and cell therapies and immunotherapy, among others. And I'll briefly cover what status we're currently at and then move on to further details. And as you all may know, in the immuno-oncology market, there are first generation chemotherapy, second and third immunotherapy, and nowadays the fourth generation targeted metabolic therapy is a thing, and immuno-oncology therapy is a hype, and everyone is paying attention. And in terms of it, and there are metabolic therapy, which is gaining a lot of attention. However, so far, immuno-oncology therapy treatment is still gaining a lot of attention, and today I'll cover cell therapy and IO target therapies, and they're specifically they belong to the third generation immunotherapy, and they among other various treatments that target this NK cell, and there are various modulators including NK cell, and there are cytokine activators among others, and there are interleukin or other agents are mainly used, and there are T cell, as cell, and there's T cell engager, and thanks to the boosting therapy of that, we can use that NK engager among other efforts. And in an hour, the 10 panel discussion will be covered, and also the pain discussion therapy is also a very important key. And I am keep telling about this issue, but CAT-T treatment is also gaining a lot of attention, and it combines with gene and high NK form and other therapies. What if we come up with treatment of such? So this idea, not only in Korea but overseas, are agreeing with this idea. So we're in partnership with other entities. Well then, why is NK cell important, and why is that idea gaining a lot of attention? So in fact, something that can kill the cancer cell really well is the characteristics of this. So for T cell, there is a specific characteristics that this antigen can be recognized this, and it can kill this. And without having to go through that process, there are stress antigens that can be directly targeted and killed by this. And actually, those NK capacity, if you take a look at it, you can take a look at cytotoxic molecules, and they harbor that. And when they meet cancer cells, they can kill cancer really well. So there are various combination with antigen, antibody, and ADC, among other therapies. And in terms of NK cells, one strength is that you can do tailored therapy, and you can expand its use. And for NK cell and T cell treatment, the biggest difference between the two is that low risk. You can work on multi-dose until the cancer cells die. So unlimitedly, you can keep administering this for a treatment purpose. So that is the key strength. And one more thing that differentiates is allergenic treatment. So T cell treatment so far recalls a self T cell, and it has to work autonomously. But for NK treatment, there are advantages for allergenic characteristics, so it can massively increase its dose. So we can prepare them and we can inject it to patients. So in terms of productivity for a company, there are a lot of benefits. So that is what the key idea. And T cell is in fact related to um, immuno-oncology and DBTM. But if it kills, it doesn't stay, but it can relate to adoptive image and it can come up with additional treatment. It can come up with additional impacts. So there are various NK therapy and the optimized immunotherapy can be worked. And what kind of directions do global companies have and how they develop immunotherapy is shown on this slide. And typically, if I would begin with NK cell, then you can work on health cancer patients or healthy donors. And for cord, you get this umbilical cord blood from a cord baby, infants. So if you categorize this and if you work on a specific way to proliferate this and use it as a treatment, and in fact, in Korea, there are many frontline NK treatments under development. Get shared over this information and proliferate NK cells and administer that into patient's body. And nowadays there are some news. Therefore, companies make iPSC, and again, they detail in NK cells, and they can manipulate genes and use it as treatment. So that is another option. And NK cell expanding, if you can proliferate um, this treatment as you want, and there are two main ideas, and whether you use pivot cell or not. And as I said, there are K and K, and they're through using genetic engineering, and you have to come. And this is known to have less side effects, but if there's tumor-associated antigen, if you can target this, then you can go conduct engineering and inject this. Or I'll move on to this very soon, but there's Antecast. This company uses cancer cells, and NK. You can use NK cell to use it as a treatment. And in terms of IO, there are cytokines that you can use, and of course, it is risky to use cytokine. However, nowadays cytokine is gaining a lot of attention, and a lot of global pharmaceutical companies are paying attention into this, and many global developments are currently ongoing. And in terms of immuno-oncology, there are various IOs are currently used, and there are co-inhibitors or NKG2 1 and or 2 are used as targets, so they're specifically used. And in terms of T cell engager, you can use bio-twice specific to use it as a NK engager to highly effectively kill tumor cells. And there are various companies, as you can see, and how and from where, which source you get NK cells is a thing, and they drive this and adopt them. And if you compare the advantages and disadvantages, then the key idea is that it can used off the shelf. So whenever a patient comes, you can just sell it and deliver it. So that is the biggest strength. And no matter what kind of cell source or NK source, you can use it as very usefully. And for peripheral globe or cord blood, you can receive those NK cells from healthy donors. And if you administer that into patient's body, what it helps is that those mature and ready cells can kill those tumor cells. And in very relatively short time, for example, 2 to 3 weeks, and you can proliferate that and administer in patients. However, the problem is whenever the donor changes, the NK's key gene changes, and that is the risk. So how we're going to work on that is the key challenge during the GSB process, and that is needed. And I briefly mentioned this, and there you would use iPSC or natural question MP courts. In terms of iPSC, of course, gene modification is done, and then there will be gene huddles, and there are gene characteristics. And the iPSC's fundamental problem is the teratoma problem. How we're going to deal with that issue is something that is clearly a challenge. And for here, cell cord, there are homogeneous characteristics. However, the ABCC efficacy is relatively low, so we need additional gene modification. And in terms, the cell treatments has a certain level of HOTL. Next, there are various developers here, and we conducted some research on them. And as I said, in Korea, there Boxel Bio or GI Innovation or other companies that work on NK cells. They're engineering. They get blood from healthy donors, and you proliferate NK cells well and inject that into patients. Is widely adopted. And other overseas companies use cell treatments that are not engineered, but nowadays Chi and K or other kinds of engineering are done to increase efficacy is currently being worked on. So in summary of this part, the NK treatment itself is a pure NK, not engineered therapy, or a slight a moderate level of moderation is done and administer that to patients can be done, or immunotherapy is widely developed, and NAT Pharma is developing this frontline, spearheading this industry, and cytokine based is NIF59 was shortly mentioned. In fact, cytokine based therapy since nowadays IO industry is gaining a lot of attention, so cytokine therapy is also gaining a lot of attention. And recently, Metatherapeutics NKIT cells recently got 4 trillion Korean won on investment, and nowadays we're investing in GI101, and this also is cytokine-based treatment, and we recently made a global deal. And there are various kinds of NK cell engagers, bispecific or tri-specific characteristics. Of course, we're taking baby steps, but we are taking various efforts, and many venture companies are giving a shot into this sector. And next, I'll briefly cover clinical phases and NKG2D or co-inhibitor. Among other stimulations are being done here, or one familiar idea is the co-inhibitor signal that you may know, simazine, XL or TIGIT, or other inhibitors are currently in progress. And likewise, there are various other kinds of phases, clinical phases. Another CAR-T therapy is gaining a lot of attention and under development. And NK treatment is nowadays gaining a lot of attention, so there are a lot of clinical trials being done, and the frequency of clinical trials are frequently growing. And in fact, one of the key limitations of the cell treatment is blood cancer. It works really good for blood cancer, but it doesn't work with solid cancer. There were many voices. However, nowadays a lot of clinical data. So if you take a look at it, of course, it works really good for blood cancer, but it the NK cell may have efficacy on solid cancer too. So there is research. So we will keep contributing and putting efforts into this IO treatment and NK cell therapy industry. And next slide. This shows visually the entire market, and there was a boom skyrocketing. It shows 129% of growth rate, and if you take top five companies, it shows 129% of CAGR growth rate in total. A lot of global pharma companies are paying close attention, I suppose, because of this growth.
그러면 이제 왜 글로벌 제약사들이 관심을 가지고 있냐?
Well, then, why do global pharmaceutical companies are paying a lot of attention in this industry? Is that why are they paying attention into IO treatment?
간단히 말씀드리면
So, in order to
NK
answer
셀
that, I'll
자체가
briefly
하나만
cover
보면
this part
영향력이
again.
있을 수 있다.
So, NK cell itself can have a lot of
기존 정통적인
high
이용하는
IO
사용법을 NK 셀
immunotherapy
자체가 잘 인식해서
efficacy. So, NK
관심을
cells
줄 수
can be
있고,
well recognized
그다음에
and
다른 여러 가지
treat
이네이트
this, and
이뮤니티
their
반응이라든가
innate
어댑티브
immunity.
이뮤니티의 반응도 같이 이끌어낼
So,
수 있다.
adaptive immunity can be
현재
induced as well on
다양한
top of
클리니컬
it.
시도들이
And there are
있고
many clinical
시험에
trials
결과가
are
되게
being done,
긍정적인
and they are
여러 가지
showing bright
다른 cancer
potentials
치료제랑
and
달리
profiles. And unlike other T cells,
되게
it
안전한
can work
프로파일링이
on
있다는 것을
targeted
알아주면서
treatment, and it is very safe.
되게 관심 있게
So that is why the global market is paying a lot of attention into this. So they are paying attention to IO.
NK 표적형
And NK targeting IO treatment, and there are various goals, and there are hurdles, and there are approaches.
당연히 우리가 목표라는
And
건
of
얼마나
course,
잘 살산시킬 수 있고 그 살산시키는
making a goal
과정에
is how well we are
얼마나
going to kill
안정성을 보장받고
tumor cells and
그거를
how
평가하는
safe we're going to
그리고 실제로
make
NK
that.
세포 치료제 시장만 따로 떼어놓고 보면
And
이게
if
진료로서
you
엄청나게
think of
가격이
NK
비싸기
cell, then
때문에
the cost
스스로
can be
어떻게
really
보면
high. So how are you going to decrease the cost?
약을 개발하는 기업이기 때문에
And since
기업의
we're
입장에서
a pharmaceutical
시장에서
company that develops drugs, we have to decrease costs and how well effectively we can treat our patients is the thing. So we have to take that all of those into consideration. So from cash and potentials.
거기에 해당하는 어프로치도 우리가
So
NK
these
세포를 익스비보 시스템,
approaches.
익스플리트
So
시스템
how are we
이런
going to
것들
expand
가지고
this, and how
파이프라인을
we are going to develop this cytokine-based platform, and how are we going to
기존의 이제
develop this
성공한
platform for
키트로다
other
인슐린
Keytruda
같은 여러
developed by
가지
Samsung
성공했던
or
약과
other
비교해서
successive
튜머
treatments if
마이크로라이저े이션으로
we
NK
take
세포 잘 들어갈 수
compound,
있게끔
compound
전략을
administration among other strategies can be used,
셀베도메나
and
셀바이오에서
Parcel Bio or
핵심 같은
among
경우는
other
습다화시키기 위해서
companies are
오토메이션
also
시스템,
taking this approach, an automation
디지털라이제이션에서
system and
전문적인
cash
그런
value system,
자동화
among
부분에서
other
GMP를 도입해서
autonomous system can be used for
그래서
this.
대표적으로 저희 회사 데이터
So one
NK 세포
here, there are some representative data,
저희가 지금 GI10이라고 가장 앞서 있는 면역형 항체
and this
중에서
GI 101 is the
항체입니다.
key IO treatment of our company, and currently
미국 MSM과
US MST mark and key
준비 중이고 국내 재생산에서
licensing
이
is
세포
ongoing,
치료제가
and we
이
got
면역형
approval.
항체의 이제 결과를 잠깐 보여드리면은
So
이제
I'll
원숭이
show you
에서
this
이제
brief
저희가
results,
진행한
and we conducted
체력
experiment,
시험인데
efficacy experiment
이게
on monkeys,
IL2 기반이기 때문에
and this is
IL2 잘
IL-2
보여주는 CD8
based,
세포를
and P
접목해서 항암
T
효과를
cells are
높여볼 수도
used to
있고 T
increase
세포뿐만 아니라 NK 세포도
immunotherapy
되게 많이
efficacy, and
증식시키는
also
세포이기
we
때문에
were able we can
여러분들
proliferate NK cells.
일종의 NK
In
세포의
that sense, we can
아고니스틱
optimize this NK cells, which is agnostic, and we can activate these cells. So that is the basic characteristics.
저희가 이
And
일본
here
파이프라인
some,
말고 다른
I
일본
see some
파이프라인이 이
glitches
파이프라인은
here, but
T셀보다는 NK
those
셀을
pipelines,
조금 더 많이 증식시킬 수
instead of
있는
T cells, we can proliferate NK cells more.
그런 형태의 파이프라인도
So that we are currently working on this pipeline as well.
해당 그 일본 N 파이프라인 같은 경우는 글로벌
And for
제약사에서 개발되고 있는 NK 셀 액티베이터고
GINON, compared
저희가
to other
구체적으로
activators from other
공개되고 있는
companies,
의무적인
based on our
파이프라인이
public information
상당히
here,
우수한 NK
our
셀을 이미
pipeline
정보 안에서 올릴 수 있다.
can significantly increase our efficacy like this.
면역 항암제 조금 아까 모나리지밥을 잠깐 말씀드렸는데
And
모나리지밥 같은
I also mentioned monalizumab, and it
제공하는
uses NK
NK보다
for
혈전에서 잘 활성화하는
anti-cancer, so it
식물성
can
엔게이저를
work
가지고
well in the human body, and it also
그리고
uses
제공해주는
engager.
방사능 제어셀에서 하고
And
있는
J-Cell, which is a partnering
NK
company of
치료제예요.
ours, is also working
저희가
on
그
this NK
자체
cell,
활동을 잘
and
줄
we
수
have
있기
our
위해서
own
실제로
platform to
암살당할 수 있는
proliferate this
제어되는 것들을
and
확인했기
see
때문에
if we
저희는
can
이제
actively
K오염이라는
kill
혈액암을 사용했을
cancer
때
cells. And
보시면
we
NK셀이
used
잘
this one
암살되고 이제
on the
매치매치가
TOFP
되면서 코어를
NK,
정상적으로 죽일 수 있는
and
그런
it
데이터를
created for
보여드렸죠.
to kill tumor cells.
그게
So
조금
we
더
do have
나아가서
that data.
폭발
And on
증식을
top of that,
잡기 위해서
in
카이
order to
비행형태가
proliferate
아니라
that, instead of
그
Chi-NK, we
화학적으로
used
한 형태인 나노
chemotherapy to
데이터셀
nanotherapy
플랫폼을
to
가지고
come up with
보여드리고요.
this platform, so we could detect this research
그래서
results.
지금 최근에 그러면 이제 모든 걸 종합했을 때 그럼 이제
So
NK
if we combine all the
생물치료제를
data
완전히
here,
해결하실
then
거냐?
can we get rid of all the
해서 앞으로 이제
challenges?
우리가 좀
Then
더 주의 깊게
we need
살펴봐야
to pay some
되겠지만은
more close attention.
이제 그 다들 아시겠지만은
And as you
암
may
발병
know,
기준이 하나의
cancer
발병 기준으로 관계된 것도 아니고
does not
하나의
occur
치료법까지
based on one
적용하는
reason, and you
방향이
cannot use
뭔가 이제
one
유행어처럼
treatment
되게
to
힘들기 때문에
treat it.
최근에 이 자료는
So this
직접적인
recent
수치에서
data
그렇다고
was
생각을 하기
from
어렵게
in
실제로
2018 from
혈액형이
Switzerland,
없는 사람이
and
보게
a
되기 때문에
pediatrician doctor
다양한
announced
치료법을
this. There are various
번갈아가면서
treatments, and if you
그걸
combine
유효한
various
걸로
treatments,
진행해 보시는
then
게
you can
첫
come up
번째.
with
그다음
effective
항암
therapy
백신,
measures.
그다음
And there are
사이토카인,
anti-cancer
그다음
vaccine,
NK
cytokine, and
치료제,
NK
그다음에 면역
treatment
항체까지
or
같이 병행하는
immunotherapy.
건데
If you combine all of
되게
them,
복잡한 형태에 있어서
then it
오히려
is very sophisticated, and if you administer this, then it can be
치료법들이
worked,
좀 유효한
and
효과가 있기 때문에
they
우리가
are
NK
effective.
세포 치료제나
And NK
NK
treatment
오염,
or
NK 표적형이 유행어가
NK
어쨌든
targeted
관심 있게 지켜보긴 하지만은
IO therapy, we
적극적으로
are paying a
다양한
lot of
치료
attention,
방법을
but we
있습니다.
I think
제가
it
말씀드리고
needs that we
싶습니다.
should combine various technologies or treatment like this. So that is it for my presentation, and thank you very much.